The Python-based laboratory, a hands-on guide for scientists and engineers, provides a learn-by-doing approach to acquiring the Python programming skills needed to implement computer-controlled experimental work. This book is not a manual-like presentation of Python. Rather, the Python-based laboratory leads its listeners to mastery of the popular open-source Python computer language in its role as a powerful laboratory tool by carrying out interesting and relevant projects that explore the acquisition, production, analysis, and presentation of digitized waveforms. Listeners who are assumed to have no prior computer programming or Python background begin writing meaningful programs in the first few sections. The Python-based laboratory can be used as a textbook for science and engineering instructional laboratory students who are being taught up-to-date Python-based experimental skills. The book also works well as a self-study guide for professional laboratory researchers, industrial engineers, hobbyists, and electronics enthusiasts seeking to automate tasks using Python. Topics covered include the control of data acquisition devices, including multifunction data acquisition hardware and IEEE 488.2 interfaced standalone instruments, data file storage and presentation, digitized data concepts such as resolution, sample frequencing, and aliasing, and data analysis techniques, curve fitting, and fast Fourier transform. As listeners work their way through the book, they build several computer-based instruments, including a DC voltmeter, digital oscilloscope, DC voltage source, waveform generator, blinking LED array, digital thermometer, spectrum analyzer, and frequency meter. Each chapter concludes with a do-it-yourself project and a use-it example, as well as a healthy selection of homework-style problems, allowing listeners to test their understanding and further develop their Python-based experimentation skills. Python has become a very popular programming choice for laboratory and industrial automation in recent years, often replacing the use of the industry-standard languages LabVIEW, product of NI, formerly National Instruments, and MATLAB, product of MathWorks. Reasons for Python's growth in this area include the following. Python is free and open source, in contrast to the commercial products LabVIEW and MATLAB, making it an attractive option in academic, research, and industrial laboratories. Python is widely adopted in education. Because it is relatively easy to learn and transfers well to other domains such as scientific modeling, web development, and data science, it is not unusual for today's students to be taught and then use Python in one or more of their courses.